Okay, let's talk about household circuits. This is a little bit out of place because we haven't talked about AC or alternating current. Household current is alternating. So, some of what we talk about here, we won't talk about the oscillatory nature. We'll talk more about current and voltage and things like that, where we're talking about the RMS voltage. In any case, how does a utility company deliver electricity to your home? Well, typically they deliver it through a pair of live wires. There are actually two live wires with a RMS voltage of about 120 volts. The other wire is connected to neutral, which is connected to the ground. And really, it's the potential difference between the hot wire, the live wire, and the ground, which generates the current that flows through your different devices. Now, I said two live wires. There's two wires which are at opposite polarity. One's at 120 volts. One is out of phase. It's actually negative 120 volts with respect to that. So typically in the home delivery, you can get 120 volts compared to ground, or 240 volts if you take the difference between the two live wires. So it enters the meter. The meter keeps track of what current that you use. After it passes through the meter, it passes through your circuit breakers. Circuit breakers are safety circuits that are meant to cut off the flow of current if you try to put too much current through a wire. If we send too much current through a wire, what's going to happen is it's going to get hot, the insulation can become damaged, it can then discharge and start a fire if it reaches a high enough temperature. So this branches off into parallel circuits. Everything in your home you want to be 120 volts. And we know with parallel circuits, everything has the same voltage, so we keep it at 120 volts. But when we look at it coming into your home, again, usually the service wire comes in, depending on how you're receiving the electricity. Oftentimes they're now using aluminum wire. You won't see a red, black, and white wire. But the old copper wires would typically be color-coded like this. And again, the red was in at 120 volts, the black was in at 120 volts, they were out of phase with one another, so the potential difference was 240. The neutral would represent the voltage of the ground, and this would then go to a circuit breaker box. And the interesting thing is here, you've got two hot wires, which are 240 volt difference between one another, and you would alternate between the two. So if you wanted to use 240 volts, the breaker would actually be doubled for that appliance. So for instance, this circuit right here is not only at a higher current than most, okay, it also delivers 240 volts to, say, an electric heater, an electric dryer, an electric stove, an appliance that's going to need a lot of power. Okay? Most of your breakers are rated at 15 amps, which means that if you exceed that in a short amount of time, they'll trip. If you exceed 80% of that over a long period of time, they'll also shut down. And again, that's to protect the wires from becoming overheated and damaged. Larger utilities, again, will be rated at higher currents before they trip. How do these circuit breakers work? Some of the circuit breakers were actually designed to use electromagnets, where the magnetic field would become greater as a current would pass through them and trip it. Most circuit breakers, however, actually use bimetallic strips. As the current goes through them, the bimetallic strip heats up, and as we saw with the thermostats, it begins to bend, and if it bends enough, it actually goes into this little divot right here, and that causes the contact points to lose connection. You have to reset this breaker. Once it opens, it has to be reset manually before you can restore the power there. Typically, if you have a breaker that trips like this, try to figure out what happens. If it's tripping for an unknown reason, it may indicate that something is damaged and drawing more current than what is safe. Eventually, these do wear out over time, so it may be tripping also because it's just an old breaker. Again, here's the interior workings of the breaker. It's a little more complicated than the diagram that we showed there. But again, here's a switch that you manually move back and forth to set and reset. Circuit breakers are not 100% guaranteed at protecting against a fire starting from electricity. Basically, problems in home wiring start about 40,000 home fires per year. And about 350 people are killed in these fires. About 1,400 people are injured. So fires can happen whenever you have a short, when you have a damaged wire, and current is jumping from the wire itself to something else that gets hot. And if it gets hot enough, it can ignite some type of combustible material. Now, normally circuit breakers are just there to trip if there's too much current being drawn. You can still have a short that doesn't draw enough current to trip the breaker, but draws enough current to start a fire. Okay? If that happens, the breaker's not going to do anything to protect you. There is something called an arc fault circuit interrupter. And these are specialized breakers that you can actually buy. They're very expensive, but they're much safer than the standard breaker. Not only do they trip whenever you exceed a certain current, and this one's rated for 20 amps, they also detect spikes in the voltage, which may or may not happen if some type of shorting is taking place and it's arcing onto another object. So these AFCI, arc fault circuit interrupters, are actually very important for preventing electrical fires, because usually the fires that start due to electricity are started by an electrical short. You can still have things like motors which will seize up. Usually they should trip a circuit breaker, become very hot, and become an ignition source. But almost always it's some type of short that takes place, electrical short that starts a fire. Now, household wiring, most of the wiring we say is at 120 volts. Sometimes we say it's 110 volts. It's alternating current, so it oscillates back and forth over time at actually 60 cycles, or it oscillates at 60 hertz. The wire is not positive negative. That's not like what we have with DC. We've got a positive terminal and a negative terminal. These circuits are a hot wire which is oscillating. Okay, sometimes it's positive, sometimes it's negative, and a neutral wire which is going to return the current. Now, in some cases, we say the circuit is polarized. That means that the black wire must be connected in a certain way to our device, and the neutral wire must be connected in a certain way. Do you ever see these plugs? One end is thicker than the other one. That's a polarized plug where it only is able to go into the socket one way. Some circuits are polarized, some are not. And you can see some different plugs. Here we have a bigger prong here and a smaller prong there. Here we have a ground connection right there. Here we have a 240 volt connector right here. We have two hot wires, and we have a neutral there too. And again, 240 volts is typically reserved for really power-intensive appliances. If you have an electric oven, if you have an air conditioner, large air conditioner, not just a window unit, if you have a large electric heater, hot water heaters are normally hardwired, so we don't plug them in. But you see this unusual shaped plug where you couldn't plug a typical 110, 120 volt appliance in there. And again, one of the inserts is at 120 volts, another one's at another 120 volts, and the third prong is neutral or ground. And you can see that there are many different plug standards that are available. Probably the most typical outlet looks something like this, which is polarized. You've got the neutral, which is the bigger, the hot, which is the smaller, plus a third prong for the ground. 20 amps, you'll see sometimes this the neutral will have this little prong that goes out this way, that indicates that it can take higher currents than most circuits. And again, for 240 volts, you also have different, here's the one that we just looked at, where you have two hots and one neutral.